You've seen this problem before. F of x is equal to 3x minus 1. We want to try to approximate the area underneath the rectangle, or underneath this function, excuse me, on the interval from 1 to 4 using 6 rectangles. And here's exactly the work that we saw and used, and we ended up with an approximation of 21.75. What happens if we want to change and do the same kind of approximation but use the left endpoints? Well, all we need to do is replace I with I minus 1. In other words, we want our left endpoints to have a subscript that is 1 less than the actual number of the interval. So we can still think of this as a summation, I equals 1 to 6, but now it's going to be of 1 plus 3/4 times I minus 1. And that's the only adjustment we need to make. We can replace I with I minus 1. We can clean that up a little bit. That's the summation I equals 1 to 6. We're going to end up with 1 minus 3/4. So we're going to end up with 1/4 plus 3/4 I. When we do that, that's going to be the only difference we get. We get 3/4 I when we distribute. We also get a negative 3/4. Again, netted against the 1, we get 1/4. So let's go back to the calculator for a moment. And we've just recently done this sum, gotten 21.75. So let's bring that back up again. I'm going to press second and the enter key, which takes me back to a previous entry. And I'm going to go back with my arrow key until I get to the 1 that I need to replace with 1/4. And actually what I'm going to do is I'm going to stop on the plus. Now, if we just started typing divided by 4 to put the fraction 1/4 in here, we'll over-type everything. But if we press the second key and the delete key, which takes us into insert mode, we can now type divide 4 and have it inserted and not lose anything. So we're able to reuse the previous entry, edit it a little bit using this insert idea, and then press enter and very quickly get another estimate. In this case, our left endpoint estimate is 17.25. So if we go back here, we'll see that we get 17.25. Since the function 3x minus 1 is a monotonic function, these two numbers, right endpoint and left endpoint, will give us upper and lower bounds of the area. In this case, since this is increasing monotonic, the right endpoints gives me an upper bound and the left endpoints give me a lower bound. That is, the exact area is somewhere in between those two values. If the function had been decreasing monotonic, then the right endpoints would have given me the lower bound and the left endpoints would have given me the upper bound. And if the function is not monotonic, that is not either always increasing or always decreasing on the interval, then all bets are off. The two numbers you get from estimating using right endpoints and left endpoints could give you an upper and lower bound. They could both be upper bounds or they could both be lower bounds. So be careful about how you interpret this information once you have it.